Let the world around you soften. Let the sounds of your room, the weight of the day, the very sense of the present moment gently dissolve. We are about to embark upon a journey. This is not a journey across the familiar landscapes of our world, or even to the distant glittering stars you see in the night sky. This is a voyage backward through the silent, bottomless, and profound ocean of deep time. Our vessel is your imagination, and our course is set for the very beginning. Our destination lies 4.5 billion years in the past. Allow your mind to truly grasp the immensity of this number. 1,000 years is an eternity to a person, a span that contains empires and ages. 1,000,000 years is a geological breath, a length of time so vast it carves canyons and raises mountains. We are traveling to a moment 4,500 million years ago, a time so remote, so alien, that our own planet was not yet a planet. It was merely a promise, a whisper in a cosmic cloud. This is a journey to a time before time itself, as we know it, had begun. Before the first dawn had ever broken across a solid world, because there were no solid worlds to greet it. Before the first drop of rain had ever fallen, for there was no atmosphere to hold the clouds, and no ocean to receive them. We are traveling to a time before the very concept of a day or a year had settled into its steady, familiar rhythm. The dance of celestial bodies was just beginning, its choreography still wild, chaotic, and unwritten. Let us drift now into this primordial darkness. The sun is here, but it is a younger, fiercer, more unpredictable star, casting its brilliant, unfiltered light into a vast, swirling disk of matter that surrounds it. This is the solar nebula, a colossal, rotating cloud of hydrogen, helium, dust, and ice. It is a cosmic nursery filled with all the raw ingredients, all the scattered atoms forged in the hearts of long-dead stars that will one day build everything we have ever known. It is from this elemental chaos, this patient and silent cloud of possibility, that our story begins. Here, in the profound quiet before creation, we will wait and we will watch. As we float in this serene, yet potent emptiness, a question begins to form. It rises not from words, but from the very stillness of this place. It is a question that lies at the very foundation of our existence, the root of all our other questions. What was it like? What did it truly look and feel and sound like at the very moment our Earth was born? What was the nature of the forge that created our world? Forget, for a moment, the blue and white marble you know. Forget the sprawling continents, the deep oceans, the gentle sky. Try to imagine the raw sensation of a world in the process of becoming. The unimaginable heat, the sheer, sublime violence of creation on a scale that defies all human experience. How was our home, this small, precious sanctuary of life, summoned from the chaos? And how, in the midst of this cosmic furnace, did it gain its constant, silent companion, the moon that hangs like a memory in our night sky? The story we seek is not one of kings or empires, of triumphs or tragedies, written in the fragile books of human history. This is the story that comes before all other stories. It is a tale written not in ink, but in fire and gravity, in cosmic dust and molten rock. It is an epic, not of people, but of a planet. It is the story of our home, the ultimate origin story. Tonight, we will become cosmic detectives. We seek to answer this profound question by examining the clues left behind, the faint geological echoes of a cataclysm that no eye witnessed. We will journey back to the very first day of our world, a day that may have lasted for 1,000 years, to understand the violent and yet strangely beautiful creation of the Earth-Moon system. This is not just the story of a rock in space. It is the story of how the conditions for our own consciousness came to be. It is the story of how we, in the most fundamental sense, came to be. The image of our solar system that lives in your mind is one of peace. It is a vision of clockwork precision, of planets tracing their elegant, predictable ellipses around a steady, benevolent sun. It is a celestial dance of sublime and silent order. Let go of this image. For the time we are in, this 4.5 billion-year-old past, is a time of profound and violent chaos. The swirling disk of gas and dust we first imagined has begun to change. Gravity, the silent and patient sculptor of the cosmos, has been at work. In the cold expanse, tiny grains of dust have clung to one another, growing into pebbles, then boulders, then something more. They have become planetesimals, the seeds of planets. Imagine millions of them, jagged, mountain-sized worlds of rock and metal and frozen gas, each one a wandering orphan of creation. There are no stable orbits here. There are only wild, eccentric paths, crisscrossing and overlapping in a three-dimensional web of immense complexity. This is not a dance. It is a shooting gallery on a cosmic scale. Every planetesimal is both a bullet and a target. Their paths are not governed by serene mathematics, but by a brutal gravitational lottery. A near miss can send two bodies spinning off in new, unpredictable directions. A direct hit is an act of both unimaginable destruction and breathtaking creation. In the silent vacuum of space, two mountain-sized worlds collide. There is no sound, only a brilliant, silent flash of incandescent light as solid rock is vaporized in an instant. The energy released is beyond any human measure. The two bodies might merge, becoming a single, larger, molten object. Or they might shatter, creating 1,000 smaller projectiles to continue the cosmic barrage. For millions of years, this was the normal state of being. The space between the worlds was not an empty void, but a teeming, treacherous wilderness of tumbling rock and ice. From the surface of any growing protoplanet, the sky would have been a terrifying spectacle. A constant stream of celestial visitors, some passing as fleeting points of light, others growing monstrously large in the heavens before their inevitable, world-shattering impact. This was the first great obstacle to creation, a relentless, planet-killing storm of debris. And yet, this very violence was the engine of growth. Every collision, every act of destruction was a necessary sacrifice. It was the way the universe gathered its scattered dust into the concentrated, magnificent forms of planets. Our young Earth was not hiding from this storm. It was growing in the heart of it. Amidst this celestial hailstorm, one planetesimal has, through luck and gravity, grown faster and larger than its neighbors. This is the proto-Earth, but you must not picture the world you know. Banish the blues of the oceans, the greens of the forests, the whites of the clouds and ice caps. What we see before us is a different entity entirely. It is a glowing, incandescent sphere of molten rock and metal, a seething, global ocean of magma, thousands of kilometers deep. Its surface is not solid, but a turbulent, churning skin of liquid stone. constantly punctured and ripped open by the never-ending rain of smaller asteroids and comets. Each impact creates a brilliant, silent splash of unimaginable scale, sending superheated, vaporized rock high into the thin, primitive atmosphere. This proto-Terra is a hellscape of profound intensity. Its sky is a toxic, reddish-brown haze of carbon dioxide, nitrogen, and sulfur compounds, choked with the dust of countless collisions. The pressure at its surface is crushing. The heat is so extreme that it would vaporize any modern spacecraft in an instant. This is not a cradle for life. It is a furnace of planetary formation. It is a world still glowing with the trapped heat of its own violent birth, a colossal ember in the darkness of space. And yet, within its molten heart, a process of profound importance is occurring. The heaviest elements, iron and nickel, are slowly sinking through the liquid rock, drawn by gravity toward the center. They are accumulating to form a dense metallic core, the future engine of our planet's magnetic field, a shield that would one day protect all life to come. This world is a monster, but it is our monster. It is the Earth in its terrifying infancy, and it is not alone. As this glowing proto-Earth traces its path, another world is on a converging course. In the language of our story, we will call it Theia. In the old myths, she was a titaness, the mother of the moon. Here, she is a planetary body in her own right, a fully formed world approximately the size of modern-day Mars. She is not a mere asteroid, but a peer. Theia has lived her own life of violent accretion, gathering her own mass, forming her own iron core. She is a traveler, a wanderer, on a long, looping orbit that has, over millennia, brought her closer and closer to the orbit of the proto-Earth. This is not a story of malice or intent. It is a story of gravity. For millions of years, these two worlds have been subtly influencing each other, their gravitational fields reaching out across the void, gently, inexorably, pulling them toward a shared destiny. They is not aiming for the proto-Earth. It is simply falling, caught in a gravitational dance from which there is no escape. Its trajectory is now set. The final few million kilometers are closing. In the grand, silent theater of the cosmos, two of the principal actors are about to take center stage, destined for an encounter that will shatter them both, and from their wreckage, create something entirely new. The traveler is approaching. From the seething, molten surface of the proto-Earth, a new, terrible star has appeared in the sky. It is Theia. For millennia, it was a point of light, a fellow traveler in the darkness. But now, it is no longer a star. It is a world. It grows larger with each passing moment, its own scarred, glowing surface becoming visible across the shrinking gulf of space. The two planets are now locked in a final gravitational embrace. Their molten surfaces begin to deform, bulging outward, reaching for one another across the void. Tides of liquid rock, miles high, are pulled up from the depths, a silent, planetary scream. Imagine the final hours. The remaining distance is crossed in what would feel like an eternity. They fills the entire sky of the proto-Earth, a colossal, fiery ceiling blotting out the distant sun. There is no sound, there is no atmosphere dense enough to carry a warning roar. There is only the inexorable, silent pull of gravity, a force now so immense that it warps the very fabric of space between these two doomed worlds. This is the end of their separate journeys, the end of two distinct histories, two paths that have been winding through the chaos of the early solar system, destined for this one singular moment of union. There is no escape. This is not an accident, but a consequence. A destiny written in the language of physics. A promise made the moment these two bodies first began to accumulate mass. Every asteroid they ever absorbed, every smaller collision they ever survived, has led them here. It has all been a prelude to this final, transformative act. In these last moments, we must understand the nature of this event. It is not an act of pure annihilation. It is an act of cosmic alchemy. It is the universe using its most violent and powerful tool to forge something new, something that neither world could have become on its own. This is the ultimate sacrifice of creation. Two worlds must die so that a new system, one capable of nurturing life, can be born. The energy about to be unleashed will be incomprehensible, enough to vaporize rock and metal on a global scale. It is an impact of such magnitude that it will redefine the very meaning of the word day. From this destruction, a companion will be born. From this fire, stability will emerge. The stage is set. The actors are in place. The silent, cosmic clock has counted down to 0. The space between them is gone. The moment has arrived. And in the profound quiet of the void, a world is about to be unmade and remade forever. An impact of unimaginable scale. A world unmade and remade. A companion born from the fire. The story we have just imagined is the most pivotal moment in our planet's 4.5 billion year history. But it is a story with a profound challenge. There were no witnesses. No eye, human or otherwise, saw this cosmic collision. No mind was present to record the sheer, terrifying beauty of the event. It happened in the silent, empty theater of the early solar system, an epic drama played out to an audience of none. And so, the question that has haunted scientists for centuries is, how could we possibly know? How can we tell a story with such certainty when its first chapter was written in an era from which no direct message could ever survive? The answer is that the event, like a great cataclysm, left behind a crime scene. The evidence was not destroyed in the fire. The fire itself forged the evidence. The clues were not lost to time. They were locked away by time, deep within the very stone of the earth and its newfound moon. To understand what happened, we must change our perspective. We must cease to be passive listeners to an ancient story and instead become cosmic detectives. We must hunt for the echoes of the impact, the faint but persistent fingerprints of a collision that shook the heavens. Our investigation will not take us to libraries or archives, but to laboratories. Our evidence will not be written on paper, but in the atomic structure of ancient rocks. For millennia, the moon was a mystery, a silent, silver disk in the sky. But in the 20th century, humanity finally reached out and touched it. The Apollo missions, in their daring voyages, did more than just plant flags. They brought back pieces of the crime scene itself, hundreds of kilograms of lunar rock and soil, each piece a time capsule, each grain of dust a potential witness. These rocks, carried across the void of space to our terrestrial labs, held the key. They contained a silent testimony, a chemical story that had waited billions of years to be read. It is here, in these precious fragments of another world, that our forensic hunt begins. We will analyze their composition, compare them to the earth beneath our feet, and piece together the story of their shared, violent birth. Our first piece of evidence takes us into the invisible world of the atom. To understand it, we must first understand a simple, beautiful fact about our solar system. Every planet, every moon, every asteroid carries a kind of chemical birth certificate, a unique signature hidden within the elements they are made of. This signature is found in things called isotopes. Think of isotopes as different flavors of the same element. An atom of oxygen will always be an atom of oxygen, but it can have slightly different weights depending on the number of neutrons in its core. The specific ratio of these heavier and lighter flavors of oxygen is determined by where in the swirling solar nebula an object was formed. A rock from Mars has a different oxygen signature than a rock from an asteroid. They have their own chemical accent, a fingerprint that tells the story of their origin. For decades before the Apollo missions, scientists had a burning question. What would the moon's isotopic fingerprint look like? If the moon was a captured wanderer from the outer solar system, its signature would be wildly different from Earth's. If it had formed near the Earth, but as a separate body, its signature would be similar but distinct. The answer was waiting, locked inside the gray, dusty rocks that the astronauts brought home. In clean rooms, under powerful microscopes, scientists carefully vaporized tiny samples of lunar rock and analyzed their composition. And what they found was not just surprising, it was a revelation that sent shockwaves through the scientific community. The oxygen isotopes of the moon were not just similar to Earth's. They were identical, a perfect one-to-one match. It was a planetary DNA test, and the results came back as a definitive parent-child relationship. This single discovery was the smoking gun. It was the first undeniable piece of evidence that the moon was not a stranger, not a neighbor, but bone of our bone and stone of our stone. The material that formed the moon had to have come from the same source as the material that formed the Earth. Any story of the moon's origin now had to explain this profound and intimate chemical connection. The first echo of the great impact had been found. The identical isotopic fingerprint was a stunning revelation, tying the moon's origin to Earth's own body. But it raised another profound question. If the moon was born from the Earth, why is it so different? Our next clue lies not in the chemistry, but in the very structure of these two worlds. It is the mystery of the missing iron. To understand this, we must first picture how a planet organizes itself. In the fiery furnace of their formation, worlds like the proto-Earth are entirely molten. Over time, a great separation occurs, a process called differentiation. The heaviest materials, primarily iron and nickel, are pulled by gravity and sink down to form a dense, metallic core. The lighter materials, the silicate rocks, float upwards to form the thick, stony mantle and the thin outer crust. Earth followed this recipe perfectly. It has a colossal iron core, an engine in its heart that makes up nearly a third of its total mass. For centuries, astronomers assumed the moon must be the same, a smaller but proportional copy of the Earth. But as we studied its gravity and density more closely, a stark anomaly emerged. The moon is far too light for its size. Image comparing the internal structures of Earth and the moon. Its density is much lower than Earth's, revealing that it possesses only a tiny, almost insignificant iron core. If it was a smaller sibling to Earth, or a captured world from elsewhere, it should have a much larger metallic heart. So, where is the moon's iron? The giant Timpact hypothesis provides a breathtakingly elegant answer. The collision was not a perfect head-on strike. They is believed to have struck the proto-Earth a glancing blow. This titanic impact was powerful enough to liquefy both worlds, but the energy was concentrated on their outer layers. The collision stripped away and vaporized the stony mantles of both Theia and the proto-Earth, blasting this iron-poor material into orbit. The dense iron core of the two planets, however, were largely spared. Most of Theia's heavy core would have plunged into the proto-Earth, merging with its own and sinking to the center. The debris that was flung into space, the material that would eventually coalesce to form our moon, was therefore made almost entirely from the mantles. The moon didn't lose its iron. It was built from ingredients that never had much iron to begin with. This physical anomaly, this strange lightness of being, is another powerful echo of that ancient impact. It tells us not only that the moon came from Earth, but precisely which part of Earth it came from. We have examined the chemical clues in the isotopes and the physical clues in the missing iron. Together, they paint a compelling picture of a colossal impact. But this evidence is static. It is the aftermath. To truly understand the event, to witness its terrifying dynamics, we must turn to our only possible eyewitness, the ghost in the machine. We must consult the power of supercomputers. Scientists cannot rewind time, but they can recreate the past in a digital universe. They build a virtual solar system, inputting everything they know. The mass and composition of the proto-Earth, the estimated size and angle of Theia's approach, and the fundamental laws of gravity and thermodynamics. Then they press play and allow physics to unfold over millions of virtual years, compressed into a few hours of processing time. What emerges is a slow-motion, ghostly reenactment of the single most important day in Earth's history. The simulation begins. We see Theia, the Mars-sized traveler, strike the proto-Earth, not head-on, but with a catastrophic, glancing blow. The energy unleashed is almost beyond comprehension. The point of impact flashes with a light brighter than 1,000 suns, as continents' worth of rock and iron are not just melted, but vaporized in an instant. The two worlds deform, their liquid surfaces splashing into one another in a silent, cosmic ballet of destruction. As the simulation progresses, Theia's dense iron core plunges through the Earth's mantle, eventually merging with our own planet's core. At the same time, a colossal plume of superheated, vaporized rock from the mantles of both planets is blasted into space. This is not a simple explosion that scatters debris randomly. Instead, the gravity of the now incandescent, rapidly spinning Earth captures this material. It forms a vast, glowing, and turbulent ring of debris around the equator. Our planet, for a time, would have resembled Saturn, but with a ring made not of ice, but of fire and molten stone. This digital phantom, this reenactment, shows us the birth of the raw material from which our moon would soon coalesce. It is the final, crucial piece of the forensic puzzle. The journey of our investigation is now coming to a close. We began with a seemingly impossible task, to witness an event that occurred in the deepest abyss of time, an event with no observers. We became cosmic detectives, and piece by piece, we have assembled the story from the echoes left behind in the stone and the stars. Now, we must consider the weight of our findings. Think of each clue as a single, isolated note in a grand symphony. On its own, it is a simple fact, but when played together, these notes create a powerful, undeniable chord. The first clue was the isotopic fingerprint. The revelation that the moon shares Earth's exact chemical signature was the first note. It told us, with the certainty of a DNA test, that the moon was born from the Earth's own substance. This was the foundation of our case, the proof of a shared heritage. But this raised its own questions. Our second clue, the mystery of the missing iron, provided the answer. The moon's strange lightness, its lack of a significant iron core, was the second note. It told us not only that the moon came from Earth, but which part of Earth. It was forged not from the whole of our planet, but from the lighter rocky mantles that were blasted away in a cataclysm. This clue added texture and detail, revealing the specific nature of the separation. Finally, we consulted our only eyewitness, the ghost in the machine. The supercomputer simulations provided the third resonant note of the chord. They gave us the dynamics, the choreography of the event itself. They showed how a glancing blow from a moth-sized body could perfectly explain both the isotopic mixing and the creation of an iron-poor debris ring. The simulations confirmed that the physics of such an impact would create exactly the kind of Earth-Moon system we see today. These are not three separate stories. They are one story, told in three different languages: the language of chemistry, the language of physics, and the language of mathematics. Each line of evidence, on its own, is compelling, but together they are conclusive. They lock into place, reinforcing one another, creating a single, coherent, and beautiful picture of our violent birth. This is the fingerprint of the great impact left pressed upon our solar system for 4.5 billion years, waiting for us to find it. The case is made. We now know what happened. The story we have pieced together from the chemical whispers in ancient stones, the physical clues in planetary structures, and the ghostly reenactments in our most powerful computers, is more than just a compelling narrative. It is a cornerstone of modern planetary science. This powerful, evidence-based explanation for the birth of our moon has a formal name: the giant impact hypothesis. In its essence, the hypothesis is both breathtakingly simple and profoundly elegant. It states that approximately 4.5 billion years ago, when our solar system was still a chaotic and violent place, the young proto-Earth did not form in isolation. It was struck a glancing blow by another planetary body, a wandering world roughly the size of Mars, which scientists have named Theia. The cataclysmic energy of this collision melted both bodies and blasted a colossal amount of vaporized rock material, primarily from the outer, stony mantles of both Earth and Theia into orbit, over a remarkably short period of cosmic time. The relentless pull of gravity gathered this glowing ring of debris together, and from it, our moon was born. This is not merely one idea among many. For decades, the giant impact hypothesis has stood as the leading scientific explanation for the origin of the moon. It is the only model that so perfectly and completely accounts for the strange triad of evidence we have just explored. It explains the identical isotopic DNA shared between Earth and the moon. It explains why the moon is so strangely light, lacking the massive iron core it should have. And it is a scenario that our computer simulations show is not only possible, but a likely outcome of the chaos in the early solar system. It is the theory that solves the puzzle. To understand its importance, we must remember that science is a living process of discovery. A hypothesis is not a guess. It is a carefully constructed explanation designed to be tested against all available evidence. And for half a century, the giant impact hypothesis has withstood that testing, growing stronger and more detailed with each new piece of data we gather. It anchors our poetic journey in the firm ground of scientific reality, transforming our imagined story into the accepted history of our world. But this powerful idea did not emerge fully formed. Its own origin story is a tale of scientific revolution. For over a century before the Apollo missions, the origin of the moon was one of the three great unsolved problems in planetary science. Scientists had elegant ideas, but each was plagued by fatal flaws. The scientific community was primarily divided among three competing schools of thought. The first was the fission theory, famously championed by George Darwin, the son of the great naturalist Charles Darwin. He proposed that the early Earth was a sphere of molten rock spinning incredibly fast, a day lasting perhaps only a few hours. This rapid rotation could have caused the planet to bulge at its equator, and eventually fling a massive blob of its own material into space. This ejected piece, he argued, became our moon. It was a poetic idea, with some even suggesting that the deep basin of the Pacific Ocean was the scar left behind from this cosmic birth. But the physics, ultimately, did not work. For this to happen, the Earth would have needed an impossible amount of rotational energy, and the moon's resulting orbit is not aligned with Earth's equator, as it should be in this scenario. The second idea was the capture theory. This suggested the moon was a wanderer, a fully formed planet from elsewhere in the solar system that strayed too close to Earth and was ensnared by its gravity. This theory had the advantage of explaining why the moon might be so different from Earth. However, the celestial mechanics of such a capture are extraordinarily difficult. It is far more likely that a passing body would either be flung away into a different orbit or crash directly into the planet. Achieving the stable, nearly circular orbit our moon enjoys today through capture is a near impossibility. The identical isotopic fingerprint delivered by the Apollo astronauts would later prove to be the final, definitive blow against this idea. The third contender was the co-accretion theory, which proposed that the Earth and Moon formed together as a binary system, condensing side by side from the same patch of the primordial solar nebula. While this seemed plausible, it could not explain the Moon's most glaring anomaly, its missing iron. If the Earth and Moon had grown together from the same building blocks, they should have a similar overall composition. The Moon should possess a large iron core proportional to its size, but it does not. For decades, these three ideas stood in a stalemate, each unable to account for all the evidence. It was the data from the Apollo moon rocks in the 1970s that shattered the deadlock. The new evidence, the isotopic match, and the confirmed lack of a large coordinate, a new explanation. In 1975, two separate teams of scientists independently proposed a fourth, far more violent and catastrophic idea, a giant impact. At first, it seemed too dramatic, too coincidental. But as the evidence was re-examined, and as computer simulations became more powerful, this radical new hypothesis was the only one that fit every single fact. It was a scientific revolution, replacing a century of gentler theories with a beautiful, chaotic, and more accurate truth. The giant impact hypothesis stands as a monumental achievement, a theory that brought clarity to a century-old problem. But in science, a good answer rarely marks the end of the story. More often, it opens the door to a room filled with newer, more subtle, and more profound questions. The great impact is no exception. While the broad strokes of the story are agreed upon, The fine details are still the subject of intense debate and research. We have found the monument, but we are still deciphering the inscriptions. The first great mystery lies buried in the very evidence that gave birth to the theory: the isotopic fingerprint. The perfect one-to-one match between Earth and lunar rocks is the theory's strongest pillar of support, but it is also its most difficult puzzle. The initial, simplest computer simulations of the impact showed that the debris ring, the material that would form the moon, should have been made mostly from the vaporized mantle of the impacting planet. This means the moon should have a chemical accent, an isotopic signature that is a mix of Theia and the proto-Earth. It should not be identical. So, how did the material from these two separate worlds mix so thoroughly, so perfectly, that the moon became a perfect chemical echo of the Earth? This is the mystery of the two worlds. Did the impact create a far larger, hotter, and more turbulent cloud of vaporized rock than we first imagined, allowing the atoms of both planets to mingle completely before anything cooled down? Or was the impact so violent that it completely obliterated Theia, blending her essence seamlessly with Earth's? The perfection of the match suggests a level of mixing that our models are still struggling to fully replicate. The second profound question is one of speed. A glowing, hot ring of debris is not a stable structure. Left alone for too long, its material would either scatter into space or fall back to Earth. For our large single moon to exist, it had to have formed fast, incredibly fast. Not over millions of years, as planets do, but perhaps in as little as a few years, or even months. Imagine a world being born from a ring of fire in less time than it takes for a human child to learn to walk. The physics required for such a rapid coagulation of matter on such a scale are extreme. Scientists are still working to understand the precise mechanics of how this cosmic cloud of vaporized rock could so quickly and efficiently gather itself into the stable, solid companion we see today. These lingering questions do not weaken the theory, they enrich it, reminding us that even the story of our own beginning is a grand puzzle we are still piecing together. The unsolved questions of isotopic mixing and rapid formation have pushed scientists to be creative, to reimagine the details of our planet's most violent day. This is science in action. It is a constant process of refinement, of testing new ideas against the hard evidence locked in stone. In an effort to solve these puzzles, two fascinating new variations on the impact story have emerged. The first is the synestia hypothesis. This idea proposes an even more violent and energetic impact than the standard model. In this scenario, the collision is so powerful that it doesn't just create a ring of debris. It completely vaporizes large portions of both the proto-Earth and Theia, merging them into a single, colossal, and rapidly spinning donut of vaporized rock. This transient celestial object, larger than a planet, is called a synestia. Imagine a red-hot, spinning top, puffed up and glowing, where there is no clear distinction between atmosphere and planet. Inside this swirling, superheated crucible, the atoms of Earth and Theia would have been violently mixed together for thousands of years, erasing any chemical differences between them. The moon, in this story, doesn't form from a separate ring. It condenses directly from this hot vapor, like a giant raindrop forming inside a cosmic cloud. This elegantly explains the perfect isotopic match. A second, less cataclysmic idea is the multiple impact hypothesis. this theory asks. What if it wasn't one single, giant impactor? What if, instead, the moon was built up over millions of years by a series of smaller impacts? In this scenario, perhaps 20 different objects, each much smaller than they, collided with the young Earth. Each collision would have blasted a small amount of Earth's mantle into orbit, creating a temporary debris disk. Over time, these disks would merge, and the debris would slowly coalesce into small moonlets, which would then combine to form the final, large moon we see today. This model has the advantage of naturally explaining the moon's Earth-like composition, as the vast majority of the material would have been chipped off our own planet. These ideas are not trying to replace the story of a great impact. They are enriching it. They show that the core concept that our moon was born from a violent collision remains the strongest explanation. But the exact nature of that violence, the precise choreography of the cosmic dance, is a script that scientists are still working to perfect. Our journey through the science of the moon's birth reveals a profound and beautiful truth. A great scientific theory is not an answer that ends all questions. It is a key that unlocks 100 new doors, each leading to a deeper and more subtle mystery. The giant impact hypothesis solved the grand puzzle of the moon's existence, but in doing so, it presented us with an even more intricate and fascinating puzzle of the details. Think of it as assembling a vast, cosmic jigsaw. The evidence from the Apollo missions and the power of computer simulations gave us the border and the main central image. We can see the picture clearly. A violent collision, a ring of debris, and the birth of two worlds from one. But now, scientists are working on the most difficult parts of the puzzle: the vast, deep blue of the sky, the subtle shades of shadow, the perfect isotopic match, the rapid formation, the exact energy of the impact. These are the pieces they are still carefully trying to fit into place. This is not a sign of failure. It is the very essence of the scientific process. The fact that scientists are debating ideas like a synestia or multiple impacts shows how vibrant and healthy this field of inquiry is. It reminds us that our knowledge is not a static monument, but a living, growing thing. Every new piece of data, every clever new simulation, adds another layer of detail to the story, bringing the distant past into sharper focus. The ultimate lesson is one of humility and wonder. The story of our own beginning is not a simple tale read from an ancient book. It is an active investigation, a story that we are still learning to read from the atoms of the moon and the earth beneath our feet. And while the precise details of the choreography are still being perfected, the fundamental truth remains unshaken and awe-inspiring. The most important event in our planet's history was a moment of unimaginable violence and sublime creation. The evidence is clear. The case is made. The great impact happened. And now we turn to its legacy. Our epic journey through the deepest corridors of time is now drawing to a close. Let us take a final moment to look back, to witness the path we have traveled, from a quiet promise to a world transformed. We began our voyage in the silent, cold expanse of a time before time, floating within a vast, rotating cloud of gas and dust. This was the solar nebula, a cosmic womb, rich with the elements of long-dead stars, a place of pure and serene potential, holding the unwritten story of every planet we have ever known. We watched as the first seeds of matter were sown, as gravity, the invisible and patient master of creation, began to coax these scattered elements into a shared dance. From that gentle beginning, we plunged into chaos. The quiet cloud gave way to a violent, celestial hailstorm that raged for millions of years. We navigated the treacherous wilderness of the young solar system, a cosmic shooting gallery teeming with millions of planetesimals, mountain-sized worlds of rock and ice on wild, unpredictable orbits. We witnessed the brutal and necessary violence of accretion, where every collision, every world-shattering impact was both an act of destruction and a step toward creation. This was the law of the new frontier. To grow, a world had to consume its neighbors, and to survive, it had to withstand a relentless cosmic bombardment. Through this maelstrom, we followed the story of our own home. We saw the proto-Earth take shape, not as a gentle blue marble, but as a glowing, incandescent monster, a global ocean of seething magma, its surface constantly scarred by impacts, its heart slowly forming a dense core of iron. It was a world forged in a furnace. And then we met its partner in destiny. They, a fellow traveler, a young world the size of Mars, whose own journey through the chaos had set it on a final, inescapable collision course. We felt the profound, silent pull of their mutual gravity, drawing them together across the void for one final, transformative encounter. We stood as silent witnesses to the climax of this cosmic drama, the final, terrible approach, the silent scream of tidal forces pulling oceans of magma into towering waves, and then the impact. A cataclysm of such scale it defies all human imagination. A glancing blow that liquefied both worlds and blasted 1 trillion tons of vaporized rock into the heavens. From this fire, we saw the aftermath, a new, larger Earth, spinning wildly, glowing brighter than a star, and around it, a magnificent, impossible ring of fire and molten stone. From this incandescent halo, we witnessed the final miraculous act, the gentle, quiet coalescence of our moon, a serene silver sphere born from the most violent event in our planet's history. The storm had passed. The first day was over. The Earth and its constant companion were finally born. The story of our beginning is now complete. We have witnessed the fire and the fury, the chaos and the creation. And now, as we stand in the quiet aftermath, we are left with a profound question. What did it all mean? Was this cataclysm merely an accident, a random act of violence in a chaotic and indifferent cosmos? Or was this terrible event the most important act of creation our world has ever known? The legacy of the collision is a beautiful and stunning paradox. It is the realization that the single most violent, destructive, and world-shattering day in our planet's history was the very event that made our world a stable, gentle, and habitable sanctuary for life. The furnace in which the Earth was almost unmade was the very same forge that created the conditions for our own existence. From an act of unimaginable violence came the possibility of peace. From a planetary death came the potential for life. Think of it as a great cosmic reset. Before the impact, the proto-Earth was just one of many growing worlds, its future uncertain. It might have become a barren super-Venus, choked by a runaway greenhouse effect. It might have been a chaotic world, tumbling through space, with no stable climate. The great impact was not just an addition, it was a complete transformation. It remade our planet from its core to its sky. It was a moment of supreme sacrifice, where one version of Earth had to be destroyed so that another, better version could be born. This is the deep truth written in the heart of our world's story. Creation and destruction are not opposites. They are partners in the same cosmic dance. The universe does not always build gently. Sometimes, to create a space for something as fragile and beautiful as life, it must first use its most powerful and violent tools. The tranquility of our world, the gentle lapping of the tides, the slow and steady march of the seasons, all of this was purchased for us 4.5 billion years ago in a moment of fire and fury. This terrible, beautiful event was not the end of our planet's story. It was the true beginning. This legacy of creation is not an abstract idea. It is written into the very physics of our world. The evidence of this ancient, creative violence is all around us, in the air we breathe, in the rhythm of our days, and in the passing of our years. The great impact did not just give us a companion in the night sky. It gave our Earth the very characteristics that make it a home. First, it gave us the gift of seasons. The Standard Model suggests they struck the Earth with a powerful, glancing blow. This off-center collision did more than just shatter rock. It knocked our entire planet off kilter, tilting its axis of rotation to the 23.5 degrees we know today. This tilt is the reason for the beautiful, cyclical dance of the seasons. As our tilted planet makes its long journey around the sun, different parts of its surface are bathed more directly in light and warmth. Without this tilt, the equator would be a permanently scorched and barren land. The poles would be locked in an eternal, ever-deepening freeze, and the gentle rhythm of spring, summer, autumn, and winter would not exist. Second, the impact gave us the gift of stability. That gentle 23.5-degree tilt would be meaningless if it were not stable. Other planets in our solar system, like Mars, wobble on their axes over millions of years, causing chaotic and extreme shifts in their climate. Our Earth is spared this fate because of the sheer size of our moon. It is an exceptionally large moon for a planet of our size, and its powerful gravitational pull acts as a cosmic anchor. It holds our planet steady, preventing it from tumbling and wobbling through space. This long-term climatic stability, lasting for billions of years, was an essential ingredient for the slow, patient, and uninterrupted evolution of complex life. And finally, the impact gave us the gift of the tides. The moon's constant, silent pull on the Earth's oceans creates a rhythmic breath, a gentle rising and falling of the sea. These tides, for eons, have mixed the waters of the world. And in the early days of life, they created a dynamic laboratory on every coastline. The endless cycle of wetting and drying in tidal pools may have been one of the crucial crucibles where the first fragile building blocks of life were assembled. The moon not only stabilized our world, it stirred it into life. Seasons, stability, and the stirring of the tides, these are the direct physical legacies of that ancient fire. And so, our story finds its way back to the present moment, back to the quiet of your room and the silent, silver disk that graces our night sky. The next time you look up and see the moon, perhaps you will see it in a new light. It is more than just a beautiful object, more than a beacon for travelers or a muse for poets. It is a monument. It is the most profound and ancient monument we have ever known. Its scarred, cratered face is not a sign of imperfection. It is the memory of the cosmic storm it survived, a testament to the violent era in which it was born. Every one of its features tells a story. Its serene, steady light, falling gently upon our world, is a constant reminder of the stability it provides, the quiet anchor that holds our planet steady in the darkness. It is a time capsule hanging in the void, a physical piece of our own planet's most formative day, sent into the heavens to watch over its parent for all of eternity. For 4.5 billion years, it has been our constant companion. It has witnessed everything. It saw the first oceans form and the first continents drift. It watched, in silent patience, as the first simple life emerged in the tidal pools it created. It has presided over the entire, sprawling epic of evolution, a silent, silver eye in the sky. The violence of its birth has long since faded, replaced by a deep and profound peace. The fire has cooled, the chaos has subsided, and what remains is this gentle, beautiful presence. It is the quiet after the storm. It is the calm that was earned through cataclysm. It is the proof that from the most unimaginable violence can come the most serene and lasting beauty. Look at the moon, and you are looking at the story of our own tranquil existence, written in stone and light. The story is now told. The journey is complete. The ancient history of our world is now a part of your own understanding. The moon, our silent companion, waits for you in the night sky, a keeper of this profound and violent secret. It is a symbol of the peace that can be found on the other side of chaos. But now it is time to let the story go. Let the images of fire and molten rock dissolve. Let the immense spans of time gently fade away. Let the cosmic story return to the stars from which it came. There is nothing more to understand, nothing more to question. The knowledge is now a part of you, a quiet whisper in the back of your mind. All that remains is the peace that was earned so long ago. The stability of our world, a gift from that ancient fire, is now yours to enjoy. Allow yourself to feel that calm. Allow your body to feel heavy and your mind to become still. The universe has completed its great and violent work, and now your only work is to rest, let go, and drift into the quiet, deep, and peaceful sleep you so richly deserve. Rest now.